Section 1.3 is open sentences. So, what is an open sentence? An open sentence is a mathematical statement with one or more variables. For example, something like 3n plus 7. An open sentence is neither true nor false until the variables are replaced by the values. I'm going to be giving you a long list of things, so be sure to pause and write, and then we'll explain them more after we get the lists written. So an open sentence, a mathematical statement with one or more variables. It is neither true nor false until the variables are replaced by values. To solve the open sentence by finding a value for a variable, in other words, figuring out what number should go in place of the variable. The replacement value is called the solution. And an open sentence with an equal sign is an equation. So to change this open sentence to an equation, I'm simply going to put a value after the equal sign. So be sure you've copied these down. Pause and take your time, and we'll talk about them as we go on. So a replacement set. This is the set of numbers from which replacements for the variable may be chosen. Sometimes you can replace the variable with any number that makes the statement true. Sometimes you're given a particular replacement set that you're supposed to use to find your answers. A set is a collection of objects or numbers often shown using braces. So rather than a parentheses or a bracket, these are called braces. And you do want to be able to write braces. An element is any object or number in the set. So the set is a collection of numbers, for example 1, 2, 7, and 9. And an element is any one of these objects in the set. Oops. The solution set is the set of elements from the replacement set that make the open sentence true. Again, get this written down and we'll do a couple examples and it'll make a little more sense. So, using a replacement set to solve an equation. So the question is, find the solution set for each equation if the replacement set is 3, 4, 5, 6, and 7. Now remember, for this particular solution, these are the only values we can choose from. So here's our first one, and there's two ways to go about this. We could either plug each number in from the solution set until we find one that works, or we can solve it like we would a regular equation. So subtract 7 from both sides, and divide by 6. I guess I should write that in. Let me write in that line of work. Divided by 6, so that n would equal 5. Since 5 is one of the numbers in the solution set, our solution is 5. And since we started with the braces, we're going to write our solution in braces. We don't always have to do that, but that's what we're going to do for right now. Oops, ran over again. So here's a little bit more. If you didn't get that, just pause and rewind and my work will show back on the screen. Okay, so this one I'm going to distribute. 5x plus 10 equals 40. I'm going to work over here in case I put another problem down. You can keep going straight down your page. Subtract 10. So 5x equals 30. Divide by 5. And x equals 6. So my solution set is 6. And again, it was one of my choices, so I'm okay. So what if we want to find the solution set of an inequality? So here's another example. Find the solution set for 18 minus y is less than 10. I'm going to rewrite that. If the replacement set is these numbers. So let's first solve the inequality. Subtract 18 from both sides, so negative y, is less than -8. Remember, if I divide or multiply by a negative number, I have to change the inequality. So y is greater than 8 is the solution for this inequality if I am not restricted to a replacement set. In other words, I could just leave this as my answer, and anything greater than 8 would work. But let's look at our solution set. I need only numbers from the replacement set that are greater than 8. So 8 doesn't work. I can use 9, 10, 11, and 12. So this is my solution set for this inequality when I am given a replacement set that is very specific. Okay, again, go back and pause if you didn't get that all written down. Always pause to write stuff down before you move on. Find the solution set for 15.5 plus 5n is less than 135. If the solution must be a positive integer. So this time, instead of giving me a set of numbers, they've given me kind of a description of what my answers can be. So let's subtract our 15.5. Whoops, hold on. So that's going to be, my pen wasn't working. 5n is less than, subtracting 15.5, 119.5. And then we're going to divide both sides by 5. So n is less than, let's see, if I divide by 5, that's going to go into 11 twice. 23.9. If you need to do that off to the side, that's fine. So n is less than 23.9, but my answer has to be positive. Again, if I was not given a replacement set, I could have used any number, positive or negative, less than 23.9. But as it stands, my solution set, since it's been restricted, has to be less than 23.9, but greater than 0. And for that matter, it's got to be an integer. So really, my replacement set is all integers from 1 to 24. So I could list them all out. Oops, and less than 23.9. So 23 is the last one. We can use dots to show that the numbers continue on. We'll talk more about this one together in class, so be sure to hold your questions till then. And I think that's it.